So let's look at calculus, and especially here we're going to be looking at tangent to cubic equation. So here we have the function f is defined. So we have a function. What kind of function is that? It's a cubic function. We have x to the power of 3, 2, and x. Okay. So what do we need to do? Find the equation of what? Tangent to the graph of f at the point. So there is a cubic equation, and at some point I'm making that up. I don't know exactly where it is. So there is this point here, x is equal to, and there is a tangent, and I need to find the equation of that tangent. Now, equation of tangent, that means what? Equation of a line. So how do we do equation of a line? Well, we know y minus y1 equal m x minus x1, a formula in our maths tables in coordinate geometry, equation of a line. Okay, so what do I need in order to use this equation? I need two items. I need the point that is on that line, and I need a slope. Okay, so do I have a point? Well, this point where the tangent is touching our graph, that is a common point. That point belongs to our tangent, but as well, it belongs to our cubic function. So if I know the value of x, which I do because that's the value of 2, therefore I can find the value of y here, isn't it? So all we do is sub that in. So we are saying f when x equal 2, it will be 2 multiplied by 2 to the power of 3. We just basically replace x with 2. We put all of those numbers in the calculator. We press equal, and we get that that is minus 21. So there is our point, 2 and minus 21. Now, what about the slope? So here, the idea that very often is used is that the slope of the function and the slope of the tangent, therefore, at a specific point is the same as the value of the derivative at that same point. So if I can find the value of the derivative at x equal 2, well, therefore, that will be the value of the slope. Okay, so I just need a derivative. So how do I derive this function? We know each element separate, and we know cubic become quadratic function. Number that doesn't have x beside it goes into 0. When we have x with no power, therefore the derivative of that is the number that stands beside x. And really, we are only applying formula to the first two elements, and it is the very first formula from our table, where it's saying when I have x taken to a specific power, when I change that to the derivative, that power goes in front, followed by x and minus 1. What happens with the number? Like in this case 2 or minus 9. Well, if I have a number here, it crosses over to the other side without a change. So applying that here, that 2 will cross over, then followed by the power, which is 3, then followed by x, and then that power minus 1. So that means 2 multiplied by 3, that is 6, x to the power of 2. And the same idea here, the number is minus 9, followed by my power, which is 2, and then x 2 minus 1. So minus 9 by 2, that's minus 18x, and 2 minus 1, power of 1. So let's create our derivative. So that means that is 6x to the power of 2 minus 18x, and then don't forget plus 5. So I need to do what with that? I need to find the value of the derivative, mean value here of y, when what? When x is 2. So all we do here, let's move that second part a bit. So all we do here, we replace x with 2. So that means I'm looking for the value of the derivative when x is 2. So 6 multiplied by 2 to the power of 2 minus 18 multiplied by 2 plus 5. And again, we put all of that in our calculator, press equal, and we get minus 7. So minus 7 is what? Is the slope. So now I can write my equation of the tangent, which is y, minus the y coordinate, which is minus 21, equal the slope, which is minus 7, bracket x, minus the x coordinate, which is 2. And here we are told we do not need to simplify our answer now. However, can't help myself. I have to multiply the brackets and change those minuses to plus. But anyway, we do not need to simplify the answer. Okay, and then that next part, we have to find the coordinates of the point of inflection of that cubic function. So how do we do that? Point of inflection at my second derivative will equal 0. So that's the point of inflection. So now we are creating a second derivative. Basically, we are deriving this quadratic into what? Linear. So second derivative, again, that 2 goes in the front. So it will be 2 multiplied by 6, which will be 12. And then x power will go down to 1. And then minus 18. Yeah, when there is x with no power beside it, derivative is just the number that stands beside x. So now we equal that to 0, which is very simple calculation. We move 18 to the other side, change the sign, and to eliminate that 12 beside x, we divide both sides by 12. And then we put that in the calculator and we get that the value of x is 3/2. Now, the only thing we have to find here was the x coordinate. We don't have to find the point of inflection, meaning the x and y. If we were to find y, what do? We will take that 3/2 and sub that back in where? Into the main cubic function f, and we will get the coordinate of that point of inflection, the y coordinate.